Hello, friends, and welcome to the Serverless Office Hours. My name is Darko, and I'm not Julian. Yes, your usual host, Julian Wood, is not here. He's on some wonderful vacation, and I'm going to be filling in today. But hopefully I can live up to his standards. And today I do have two special guests who are going to be talking to me about, what does it say here below me? Translating infrastructure as code with GenAI. So we're going to be tackling a little bit of that. It's a very interesting topic because infrastructure as code translation can be challenging because it's not just translating a language to another language or a framework to another framework. Sometimes there's a lot of specifics when a certain infrastructure as code framework or a language does things. So it's a very interesting thing to tackle. There has never been, as far as I know, maybe chat can tell me, but as far as I know, there has never been a tool that does translation from one side to the other. I know of a great open source project by an AWS hero called Ian Mackay. He built a tool called Former 2, which translates into infrastructure as code from clicks, which is shenanigans, and not just from clicks, but also from your infrastructure. So what you can do is you can point Former 2 at your AWS account and tell it, here, look at my resources, or resources tagged with whatever, and then it will generate infrastructure as code for you in whatever language or framework you have chosen. But today we're going to be looking at something different. We're going to be looking at how you can translate infrastructure as code from one language, one framework, one project, I guess, one tool to something else. And we're going to be using some Amazon Q Developer and generative AI to help us get there. But I want to ask some chat. Chat, what do you use as infrastructure as code? There's the chat on that side, just here. Yes. Let me know. Let me know. I would love to hear what's your preferred ISC framework of choice. When I started with the cloud ages ago, back then, actually, I think the closest thing to infrastructure as code I had was Ansible. But Ansible wasn't really through infrastructure as code. No, it was Vagrant. Vagrant could launch some resources in some sort of an automated way. But yeah, I don't even know if Vagrant is being used anymore. I remember provisioning virtual machines with Vagrant, so incredible. But then I moved on to like AWS and then CloudFormation, which was written in JSON back then, which is just preposterous. Then YAML came around, and Terraform was here, and then CDK, SAM, all of these kinds of things now exist. Pulumi, I don't even know, Winglang, and a couple of other tools out there exist to deploy infrastructure as code on AWS. But let's bring in my guests, Debasis and Joshua, to tell us a little bit more about how this translation works with generative AI. So, hello, friends. Welcome to the show.
Thanks for having us.
Excellent. So before we kick it off, Joshua, tell us who you are, what do you do, where do you join us from, and what is your preferred infrastructure as code framework?
Sure, yeah. So I'm Josh. I've been at AWS about 6.5 years. I'm a solutions architect here. I specialize in our serverless area, as well as a couple of other areas across AWS. Yeah. And I love working with infrastructure as code frameworks because I don't like clicking around at consoles. I don't like forgetting what I did. I don't like documenting what I did. And so these frameworks are super helpful to me. And AI has just made it, I mean, it's like a match made in heaven, right? Like you have this code that defines your infrastructure. And now AI is a lot better at writing and reading code than it is at clicking around in computer browsers, right? Even though it's starting to get good at that too. And then personally, I like SAM. I like to use SAM. I think it's super easy to use. I'm used to it, right? And it's just way more powerful than people realize as well.
Yeah. Remember SAM when it came out? It was such a great thing. It was kind of SAM is CloudFormation's little cousin. It's basically CloudFormation, which is specifically tuned for serverless applications. Uses YAML and all those things. But do we call it a macro? Is it a macro or a transformer? There's something like that. It's basically CloudFormation macros to do certain things. But
yeah, it's like a transform. But yeah, it's like what's cool is that SAM. It started out as like this transform template for a CloudFormation, but now there's all these tools in like SAM CLI where you can do like testing in the cloud. You can pull things in more easily. You can do all kinds of local testing with it. It's become sort of this toolkit and not just a CloudFormation extension, which is really cool.
Yeah, way before SAM, before one of my first cloud projects was building something like a SAM equivalent where I could write some infrastructure, but like it would be highly opinionated how it would do stuff. So like easily launching Lambda functions and EC2 instances back then was my favorite thing to do through the command line. So I like that. Debasis, welcome to the show, my friend. To tell us who you are, what do you do, and what is your favorite infrastructure as code framework?
My name is Debasis Rath. I'm a specialist solution architect. I focus on serverless technology, which is serverless compute as well as serverless integration services like API gateway, step function, SQS, SNS, and a bunch of different services. I help enterprise customers to solve their cloud native problems and build their modern application. My favorite infrastructure tool, I started with SAM as a basic. I had no exposure to any kind of IAC tool till that point. I started with SAM, and then I came to know that like it's just a cloud formation underneath. Then I spent around like four years, I guess, like exploring SAM as a toolkit, as Josh mentioned, different patterns, how to use the VS Code toolkit, bunch of different things. Last year we did like a bunch of research around Terraform as well for serverless. So right now I would say like if I had to go beyond like serverless services, I'll probably look at Terraform as my preferred choice of tool to write my infrastructure. If I'm writing like serverless, I need to deliver a project like in 8 hours. I'll supercharge myself with like SAM and other tools at my disposal and write some sophisticated serverless projects. That's the one.
Yeah, I do. I'm a big fan of how SAM handles like Lambda functions. So simple to kind of just deploy and package up Lambda functions. That's been my favorite thing. And to be honest, I don't even know how to deploy a Lambda function without like an infrastructure as code framework. I know you have to upload a zip file or something like, but what? Who even does that? So it's absolutely, especially for serverless applications, I think infrastructure as code frameworks are the must. If you're creating a serverless application without an ISC framework, what's wrong with you? Okay, cool. Let's talk about a little bit about today's topic, is about translation infrastructure as code in the world of GenAI. Now, the first question I want to drop in here. So, when it comes to these like new coding assistants, what's the benefit of using them for translation? Like, how did people translate infrastructure code in the past?
If I can take that question, the need is different, right? So there are a variety of different needs. For example, if there are like company mergers, like there are two different companies coming under a single umbrella, they are bringing in some older or like a code from a different organization, different practices. Now they are being part of a bigger organization. Now this bigger organization might have some specific needs that, hey, our code should be written in Terraform. Our code should follow this kind of like guardrails or governance, or should follow this platform strategy, right? So in those scenarios, it becomes like a task for the incoming team to translate the code from like X framework to the Y framework as a destination. And that's where like we started like thinking about like what would be the better way. And 2025 is the right time to do it with all kind of GenAI tooling. So yeah.
That's definitely the proper time to do this. Have you noticed any kind of like challenges when doing that? Like are AI agents good at doing that? Because I know there's like specific agents for language translations. Do they handle problems here as well? Like, how do you tackle that?
It really depends. Under the hood, like each AI coding assistant is trained on separate set of agents.
Yeah.
So I have used QCLI thoroughly in my journey of like translating the infrastructure as code from like one form to the other form, because QCLI is trained on a lot of AWS style coding. So it knows very well like how CloudFormation works, how SAM works, how Terraform works. So it knows the nuances, it knows how they work. Even if a particular feature is not available in a particular framework, it knows how to like work around it and give you some suggestions, right? So it basically elevates your knowledge and supplementing something that you probably do not know about a newer framework that you're working.
No, but by the way, Chad, there's a blog post. We're going to drop a link to the blog post, written by both Josh and Debasis about how does this translation work. Now, I noticed a certain step in this case. So there's something called an assessment phase. Now, I feel like this assessment phase is something. It's more than just like telling a coding assistant, here's my YAML file, do things with it, right? So tell me about how does this actually work? What's the assessment phase, and why do we care about it?
Yeah, so I can take this one. So the first step of this process that we outlined in the blog, the assessment, this is a very critical step because you're essentially analyzing the project before any translation starts. And you're validating, you're doing two things really. You're doing risk mitigation of, what are the risks of translating this? What's in here? What's it made up with? Are there any things that might be harder to handle in this translation process? And you're getting a better understanding of what that process might look like. So it's going to give you recommendations based on best practices and basically an evaluation report classifying it. So it kind of serves as the foundation for this automated translation step, and making sure it has enough context to reduce surprises and discovering issues.
So does this assessment phase have some sort of specific rules to it? Like a specific, is there a specific system prompt beyond just like make an assessment?
Yeah, so we define the rules in the library that we provide. There's a GitHub repo where you can see some of the rules we outline for that assessment phase. We're essentially telling CLI in this to classify the projects, right, as low, medium, or high complexity. And this is based on a number of factors. So this is the number of Lambda functions, the diversity of the event sources, are there any shared configurations or plugins or dependencies we should know about?
Okay. And like, is this specific evaluation or like decision being made by some sort of a decision matrix you pass on to it, or like do you just hope for the best that it does a good job at it?
No, yeah, we're definitely passing it like a very specific decision framework to work in here. Yep. Yeah. So this is and the rules files that we're providing that we're as part of the sample library here, these are adaptable to a lot of different types of projects, different complexities. So it's not something where you need like a super bespoke rule set for each framework, because the rules are really adaptable, right? So things that might apply to a lot of different types of frameworks and stacks, like, hey, how complex is this project? Can you look for these things? Can you find any plugins that might not be translatable or dependencies I should know about? These rules are pretty standardized across any types of frameworks you might want to translate. Debasis, do you have anything to add, or covered it?
No, you pointed out in the right direction, and how the rules are written. Again, there is no hard and fast rule in terms of like how you write rules for Amazon Q. You can write it in plain text. Me and Josh, what we have done is like we created our own framework. If you go to that GitHub link that he is referring to, you can basically take a look at like how we have written it. It's basically a tabular structure of saying that, hey, does this component exist? Does it use a CI/CD pipeline? Does it have a dependency? Does it build some kind of layer? So we do go through like a set of rules, I would say like 50, 60 rules, and we have weights assigned to each of those rules. And based on that weights, at the end of the assessment, we group them together and we calculate a score saying that, hey, for my need, this ISE framework is ready, like let's say like 75% to get translated into AWS SAM or some kind of destination framework, right? So that's what it does. The overall recommendation for our end customers would be to take this as an opinionated practice and evolve it for their own enterprise need. They should write their own rule set, find out their own metrics and own criteria for calculating the readiness. And based on that, they should run it through Amazon Q or any kind of coding assistant for that matter in order to calculate their readiness.
So I want to share my screen right now. I'm not sure if it's on, but this is the assignment rules .md file within the sample within this repository.
That's correct.
Yeah, so this is the one. And we see a bunch of like basically, I guess these are rule IDs or something like that that certain things are this, and this is something that you define. But again, you mentioned you can change this as well, right?
Yes.
So
this is just how you build that framework in order to calculate your own readiness. Every enterprise might have their own set of rules in order to evaluate it.
Yeah, which is also fascinating. That like this is something that I kind of like stay away from. But sure, it's easy like this. But like asking the LLM to do math is always shenanigans. LLMs can't do math. They just are really good at guessing what the result is. But like you were basically telling it to basically assign to each of these a point and then multiply the rules by the weights. I don't even know where the weight is. I guess the percentage is the weight, right? And then you get some sort of a number, and that's good. Like, I like this is a very thoughtful rule that's kind of being sent over to an LLM. It's easily human readable, and you also even kind of do something like double shotting it here by telling it what the results should kind of look like. So I do like that as well. And I see you have a bunch of rules here, but I guess we're going to get into them a little bit later. One question for you all: why did you decide to use tables here? Because I get it; it's easy for me to read tables. That's beautiful, but does LLM really care for tables? Is this a better structure for an LLM? I don't know.
Yeah. I mean, LLMs do like text, as simple as compressed text as possible. That's what LLMs like, because they have their own context window and context size. So if you design it like more, extensively with formatting, more characters, then it makes that window smaller and smaller, right? The choice why we took this way, so that we wanted to have like a human readable format, so that like somebody can maintain it as a human to enforce like rules, add more rules, keep the weights in touch. But yeah, there are better ways of like how you can optimize it.
Of course, I'm just asking because like
we're optimizing it.
Yeah.
Optimizing it for an LLM, we could use like JSON, for example, and just pass JSON in. But then again, like it's more difficult for a user to read. And LLMs are continually getting better at reading tables, right? It can look for those markers, right? Stops inside and kind of evaluate the table very, very easily as things progress.
Yeah, exactly. I mean, again, it's good at doing that. Even when I write to an LLM, I go and like I put my code in code brackets. For some reason, like I even outline what the language is for syntax highlighting. No, there's no need to do that. An LLM will understand that. But it's good to see that is existing. Okay, excellent. Well, that's pretty cool. So that's step number one. Like we do this evaluation, right? So can you walk me through this whole process of how does this translation now work, right? For example, from a serverless framework version 3 into like a SAM project.
Sure. So there is a couple of different steps that if you take serverless v3 as a source and SAM as a destination, right? So there are a couple of different things that each IAC framework does better, and the other framework probably doesn't have that feature. So once we do the assessment, we feed that assessment result into the next step, which is the translation, right? So at the translation step, now my coding assistant knows what are the areas that it needs to focus on. For example, if it found out serverless v3 plugin in my source project, plugins are something that is not available in the SAM site, right? Yes. So that might be converted into something like a custom resource, maybe backed by a Lambda function, or break it down to a separate stack. Or sometimes when you are translating them, there could be other kind of issues like circular dependencies, for that matter, when you are building all those things. Every tool has its own set of features that may not have like one-to-one mapping to the destination tool. And the assessment phases, that's why very important. We need to feed that data into the translation so that the queue or coding assistant can take a look at the source project, mix that assessment result into it, and then better generate the code and better generate the template.
Yeah. So you mentioned here serverless plugins, right? So is there a step in the workflow, for example, if I define a plugin, right? Like I import a plugin, how does Qt know what it is, right? Like, for example, if it's a relatively new, fresh plugin or something that's not super popular, like, do you utilize some sort of like MCP tools to kind of help maybe fetch, pun intended, fetch or something to get the information on that plugin, something that can search the plugin repository? Is that something that's being done here, or that's a future improvement?
We haven't done that in terms of like relying on an MCP to guide Amazon Q to do these things in a certain way. Certainly that can be done. MCPs are kind of an extension to what the coding assistant can do. And what we have done is like we have assumed the role of a developer in the loop here. And the developer would be basically taking a look at the assessment. Let's say it found out web plugin or like ES build plugin or something like that. Before going into the translation phase, they might be able to update the prompt a little bit, saying that, hey, if you see ES build in there, now you do this particular thing, right? So you kind of update the spec in that particular phase of the life cycle to better answer that, right? So that should be done in that case. Builder in the loop is certainly required. It's not a complete automated translation over there.
Okay.
Yeah,
okay, that's fair.
The assessment step. The assessment step is, if you're familiar with spec-driven development, right? This kind of modernized way of vibe coding, right? What we're doing is we're essentially in the assessment phase, we're building that specification, and you could always customize and tweak how you want that specification to look and the types of things you want to look out for during that specification approach before you go into the translation phase. So again, Debasis mentioned earlier, like an enterprise might have specific needs. If they're aware that they have a very, very specific plugin that they're relying on, they might run that in the spec development, right? So
is it also like, are you instructing a Q developer here, for example, to prompt a user saying like, hey, I've noticed this plugin? Like an example, when I work with a specific project, like something that's a little bit more esoteric, in my prompts, I tell Q developers saying, hey, listen, if you don't know what something is, please ask me. So is that a step like this, or do you see that as being a useful step here?
Yes. So when the assessment completes, it also generates a result, right? Assessment underscore result.md file that captures the entire assessment result. So when we go into the translation phase, we prompt you that, hey, go into this particular file, read the outcome, and based on that, then you go and translate it. So the input to the translation phase is like two files. One is the assessment result. Second is the translation rules. So rules and results are, the rules basically define like what to do. In this case, like if you see a plugin, wait and ask the developer to give an alternative to it. And the assessment result is basically the discovery of that particular information, right? So both of them can guide you better.
So I'm going to show on my screen right now is this is the stat specific SAM translation rule doc. So these are the translation rules, right? What you're talking about here. So this is where we talk about, always use IAM's authentication for all API methods by default, and pop development summary. That's great, right? Render template tree, auto specifications. Is there like, do you define like your plugins here as well? Like for example, if a plugin X is used, use a custom resource, or
you can define that. You can define that. For example, not all plugins may require custom resources. Some can be a simple like a pre-execution script to SAM template, and Q can build out that parent script, and it can do some of those tasks beforehand and then run the SAM deploy command. It can do that. Just that like we didn't have the need in this particular translation phase, so we didn't add it here.
Yeah. Now, does this project translate exclusively the infrastructure as code part, or does it also like do some translations of the application? It does not touch the Lambda functions or anything like that, right?
I believe it just does the ISC translation and not the code. We kind of kept the code as is. Copy the SRC folder from this to this. That's all it does.
Yep, that's correct. And it's important to note, like you're saying, you can translate between any frameworks. It's not specific to the ones mentioned in the blog, right? Going from the example we use here is Serverless Framework v3 over to SAM. But you could do the reverse. You could do all kinds of different things, and kind of based on how your enterprise growth, new frameworks that come out, things like that, you could adapt how you want to use this type of process.
Yeah. So in this case, like this file translation underscore rules MD, this is the one that defines which framework to which framework we're doing translation, right?
Yeah.
Like I can change. I could change here to switch it to Pulumi, for example, right?
Exactly.
Okay. The assessment has nothing to do. The assessment is not framework specific in a sense. Like, oh no, actually it is. Okay.
Well, it is in the sense that you're assessing it for like
specific task.
You're looking for something inside that framework, right? So different frameworks can have different considerations.
Yeah.
And one of the considerations that we thought about writing this was you're going to be really familiar with the framework you're coming from, right? Because you've been developing, you've been writing it, and you're going to know what to put in this assessment, because you're going to say, here's the types of things we put in this framework when we wrote this code. When you're going to the new one, that's where it might be a little less familiar, right? And so that's where you really need that guidance from the AI.
That makes a lot of sense. Okay, interesting. Well, so here's my ask to the chat community. Somebody should build an open source tool where you can just say, I want to translate from serverless to Pulumi, and then it should pre-populate certain assessment tasks here, at least some sort of boilerplate for people to use. So like you can have this command line tool that does all of this for you thanks to, I don't know, QCLI, for example. I like this. I like this very much. Okay, really cool. So what now? So we do this. It follows this translation document. What happens next? Like so I see here like we are basically deciding to use SAM in this case compared to serverless. Like why do we want to move to SAM in this example?
Like SAM as a choice for destination, is that what you're asking?
Yeah.
There is no specific choice. Like we are not biased towards like this framework and that framework. In some terms of the translation, all we are saying is like it is possible, and there is a way to do it. Just that like you need to make your coding assistant a bit more deterministic by providing the right specs, right rules, and right data at the right time, right? So that can accelerate your translation from X to Y or Y to Z. Just that you still need a developer in the loop in order to take those right decisions and feed the right context.
But let me ask you a question.
Mm-hmm.
Why is SAM better to be generated with a coding assistant than some other languages? I may know why, but I want to see what your thoughts are.
If you ask me, like my personal opinion, again, I'll ask Joshua as well, like what he thinks about it. But for me, like Amazon QCLI writes excellent SAM templates, right? Because of its experience, probably, like how it has been trained and all the like knowledge it has been backed by. So it writes excellent SAM templates, and SAM is like, I'm familiar with SAM as a developer, so I chose to write it in that way. That's it. Joshua, your thoughts?
Yeah, again, we wanted to build something that showcases an example, but it will be super clear that it can be agnostic to any framework. But we love the explicit CloudFormation definitions, the ability to create custom modules, right? The ability to adapt to a lot of things that might be occurring, right? So that's a big benefit. And the native integration, of course, with SAM CLI helps us test and evaluate before deployment.
That's what I was looking for. So in my humble opinion, the fact that you can do local development with SAM CLI means the world. Because unlike some other frameworks where you can't, or it's not as easy to deploy locally, you can't really test the outcomes of the change, right? So whenever you have a language or a framework that it can basically in place run or simulate its execution, you can have QCLI actually try to do SAM local invoke.
Yeah.
And if it actually does its job, it means it did its translation correctly. So, that's why choosing the right language and right framework for your coding assistant is very important. And I think in this case you're proving that with using SAM, because you can do some local development with it.
Yep.
Yeah, especially when something comes out of like generative AI, right? And it's not perfect, right? There are hallucinations. It's a stochastic process. It's kind of guessing, right? At the end of the day, but that lets you be deterministic about what you're deploying. The fact that you can use SAM local invoke, you can use SAM local start API, you can use these tools to say, hey, does this API actually work after this test before you actually go and deploy it? So right on.
I mean, here's a lukewarm take for you all. Stop using Python when using coding assistants. Python is the worst language you can use with coding assistants. It is not type safe. It is just shenanigans how you can write it. Use something type safe. Use even TypeScript. Use .NET. Use Java. Use Rust. You'll have a better time in the long run. So the same goes with a ISC framework that you can actually test when executing. Okay, excellent. So maybe we saw this rules file. So Josh, maybe you can tell me some of the best practices when it comes to creating or defining these rules / guardrails inside of this doc. Like, what should I tell it? Like, hey, just make sure one of my things are like that, or how would you go about it?
Yeah, that's a really good question. I would say, so just at a high level, we have 3 types of rule files that are guiding the different phases, right? So if we look at the translation rules, what we're doing, our goal here is to guide the conversion process. So clearly scope the source and the target formats. We want to make sure it's consistent with the assessment outputs so that it's told to reference those assessment outputs and describe how any specific patterns that we know about ahead of time should be translated. In the development phase, where it's actually kind of building the development, we want to make sure we're handling any unsupported plugins that called out in that assessment result, flag any resources that would require manual review so they're highlighted to us, and then define any organization specific logic or patterns. And just to go into that, like team standards are going to exist. Like there are coding rules, institutional knowledge. We want to make sure we encode as much of that as possible because it's going to reduce the lift afterwards, right? We want automation to be consistent and repeatable through the process. So you can think of these rules as codifying. It's a combination of instructions and codifying that institutional knowledge to make the AI think how your software engineer, to Debasis' point, right? It's acting as the software engineer carrying out this task, how that software engineer should think.
Yeah. Okay. So my question here for we love to use coding assistants, and coding assistants are very good at generative code, right? However, they do have a certain sense of randomness to them, right? If we look at their inference, we don't see their inference parameters, but I'm guessing the inference parameter called temperature is set to 0.6 or 0.7 or something. That's not incredibly deterministic. Do you see a world where somebody creates an MCP server that will manually invoke an LLM with a specific ask, with like a specific temperature set to 1, like just making sure it's incredibly rigid in its answer? Would that help here, or like have you never experienced such a randomness nature of an LLM that it's fine just to let the coding assistant do it?
Yeah, it's an interesting question. I think that there's certainly a lot of room for more deterministic approaches. I think with MCP servers, people have built, AWS has MCP servers that have been built out to do, for example, Terraform, MCP, like validation, state management, stuff like that. So I think there's definitely a world where MCP allows us to outsource some of this institutional knowledge of frameworks and be more deterministic about that. In general, like if you're building like a multi-agent AI workflow, a lot of times you outsource the need for determinism, right? You have functions, you have tools, you've got calculators and APIs, and you want the creativity and the flow and the complex and novel tasks to be handled by the AI, and you want everything else to kind of be outsourced. So I think that there's a future where that happens.
Again, I'm an old fart, and I think everything that could be rigid should be rigid. Like it should be mechanical and very much deterministic. So I mean, I see the younger generation use ChatGPT as a calculator. I'm like, don't do that. There's a calculator.
Well, it's like the examples you see. It's like how many R's are in strawberry with the LLM. It's like, or what's 32 plus 28. It's like this is not what AI is good at. Like if you know how the LLM operates, how transform operates, like it's really good at creating novel things based on guessing patterns, and it's not so good at definitive answers. And and that's why, again, to call back, that's why we have this very rules-based approach, right? It's very detailed rules. There's checkpoints where you can look at that assessment output and you could say, this is completely wrong, right? Like you have these checkpoints where we're not saying to any AI coding assistant, go out, translate my code and push it to prod. Right. We have the local invoke, we have the start APIs, we've got thorough assessment, translation, and testing and deployment steps.
Yeah. I mean, if it's a Friday afternoon, you maybe had a half a beer, and you can say, like, you know what, just do it and just SAM deploy.
Read only Fridays.
It's fine. I see here Mr. Insider saying Pydantic. Absolutely, you can use Pydantic with Python, and that absolutely helps. I encourage people to use Pydantic with Python, and that is why it's a hot take. A lot of people just don't use Pydantic; they just kind of, use Python and hope for the best. So, it's great. I think MCP servers and additional tooling when we build tools like this can only help us because you can, as you say, outsource certain actions to more rigid tasks, which can make it a lot better, like our existing MCP servers. Excellent. So now, once we do this translation, once this tool kind of follows all of the rules you set up, how does the SAM template look like? Is it like specifically like in the term comparing to the serverless template? How does it look like? Does it have the same functionality? Does it have the same resources? Like, because there are significant differences between the two frameworks, right?
Yes. So when we did this translation, taking this particular project as an example, Amazon Q tried to maintain the parity between these two projects. And when you open the SAM template, you do see like similar type of resources. For example, like an API gateway, an SQS queue, a Lambda function, roles, and all of that. It still like maintained all of those. Wherever there was a plugin requirement, we did experiment with like a couple of other projects. Wherever there was a plugin requirement, it was explicit about it. It was trying to handle that either using a shell script beforehand or using like a Lambda CloudFormation custom resource that would do some additional task, right? So that's how it was trying to overcome those certain features which are not available in SAM, right? So that try to maintain the parity. If the feature is not available, use a workaround like a custom resource or like a shell script.
Yeah. Okay, that's fair. Yeah, because there's a lot of the stuff that certain frameworks do differently, right? Like, and they completely approach it differently. Maybe they have even some sort of an outdated pattern. Do you follow like for outdated patterns, right? Is that a thing that these rules are already kind of predefined to look at, or you expect the user to define those?
Can you give us an example of like those patterns?
A bucket is not encrypted. Hey, right? Like that's something we shouldn't be doing anymore. Like all of the buckets created should be encrypted.
Mm-hmm.
Let's say if you have a serverless template that doesn't do that, would it instruct SAM to do it?
I mean, what I would rather recommend is like a foolproof like platform strategy for that one. So for example, we did a bit of research like last year in order to like where can we put all these checks, right? Should we do a fully shift left and put it onto the developer side? Should we do it on the pipeline itself that would catch these errors and fail fast on a CI environment? And where should we do that, right? Probably the answer is like kind of everywhere, and also depends on like how we want to do it. But to answer your questions, it's absolutely necessary to use some kind of tooling that can be executed by LLM, no doubt, but it has to be a tool at the end of the day. For example, if I'm using Terraform, right, I'm just taking an example over here. I'll probably use Chekhov. Chekhov is a great tool that you can write policy as a code, right? And you can take that policy as a code. You can ask Q that, hey, every time you try to do Terraform apply, before that, every time you run Chekhov run script, and if it fails, stop there. Don't do an apply. That's, again, I'm talking about just local. And you can use the same checkoff policy and you can apply it into a pipeline as well, right? Now, you are not only doing the checks, like deterministic 100% checks on your local, you're also doing it in your CI and further pipelines too, and catching them beforehand.
Exactly. Okay, that's really good. So, and this is kind of a very interesting discussion right now, because we've seen these examples of like things go wrong with like people just, Q take the wheel or whatnot, like just AI take the wheel and whatnot, just hoping for the best. And this is where I like to go back to my fellow developers, is that you have these tools to help you build things super fast, super great, all of those things. Use these tools to build tools to help you build tools. Mm-hmm. Bear with me. Terraform apply. You should create a version of something. You should use makefiles, first of all. Use makefiles. Mm-hmm. You should use a makefile and tell it anytime it runs Terraform apply, it will actually have to run Chekhov first, and it will create a file called .chekhov in the directory. And if that file doesn't exist, it will not run Terraform apply. Right? Yep. So basically introducing hard, rigid steps and telling an LLM, these are the commands you can run. And anytime it runs the command, like it's kind of augmented with other things, so like make build, and then it has to go through this other set of complexities. So you will introduce a lot of guardrails and a lot of kind of controls so it can't really make that mistake. So that would be my advice for a lot of people out there. And I actually wrote a whole blog about how to properly utilize makefiles these days. So I'm going to link it in the chat as well. Bhavin in chat is asking, what's the flow? There's a link to the article. I'm going to ask Jeffrey if he can post a link to the article once again. The blog post that was written by these wonderful two gentlemen about explaining the whole workflow of this application, and you can go and check it out there. Okay, so I mentioned this, or we mentioned this, make sure to tell it to use Chekhov, all those things. Is there some sort of a common challenge or gotchas you'd had, or developers may have, because of course they will have, when translating infrastructure code as code frameworks to some other framework?
Yeah. So, we've talked a little bit about already the plugin and dependency analysis, right? So different frameworks are going to have unique plugins, extensions that don't always have one-to-one equivalents, custom behaviors, things like that. So Q Developer or AI coding assistant in general, right, is going to help identify those and call them out when you may not notice them. It's easy for us to overlook stuff like that. So definitely want to. It's going to help you overcome that and flag things and find common patterns that you might run into. One of the things we didn't talk about is I alluded to it with why you might want to use SAM or why you want to use CloudFormation is resource translation, right? So property mismatches, for example, something might be called like a timeout in one framework, and it's like timeout in seconds or timeout. There might be resource mismatches that these you might forget to use. Everyone's been there. It's like you go through this integration process where you finally deploy something and it's like all these problems come back. And so Q Developer is a really good way to kind of like overcome a lot of those paper cuts in translating between resources. Another place those paper cuts might come up is security policies, right? IAM policies and permissions that exist in CloudFormation compatible resources, right? In SAM, you might have more ambiguous framing of some of those policies in a different framework. And so you want to make sure you're taking advantage of the CloudFormation native code, for example, if you're moving to SAM. So those are a few examples of how it might help.
Yeah. Okay, that's pretty cool. Yeah, I definitely have to be careful with those things. Have you seen like examples of like, I know your example is talking about serverless to SAM, but if you do a little bit more complex scenario where you want to translate serverless or SAM into CDK, because while CDK is infrastructure as code, it's a lot more than just infrastructure as code. There's a lot more complexity. It's a project, a language, libraries, yada yada. Have you seen that happen as well?
Yeah, I think if you were moving to CDK, right, the more complex the project and the more different the stack types are in the frameworks, the more robust your rules are going to have to be, right? So that's the thing, is you might just have to give it more guidance or leverage an MCP server like we called out to say, hey, call this AWS Docs or, AWS Docs MCP server or CDK or well-architected MCP server to make sure that this is accurate and that you're leveraging the right constructs and things like that. CDK especially, because the way that it uses constructs is going to add a little bit of complexity. So I haven't done it yet. This is something we alluded to, but yeah, I would just recommend more definite rules in that case, or again, calling out to more, I guess, first-party sources for that type of information, right?
Of course. Well, then let me brainstorm an idea with both of you. So here's how I would do this, and you can tell me if I'm wrong. I'm just literally guessing right now. So if I would be building a tool that would translate something to CDK, due to the different nature of CDK and the vast differences between like SAM or serverless and the way the CDK is built, I would actually make it a two-step process. Like your thing is two-step, but like I would like literally divorce the two steps. So step number one is assessment, just the assessment of the current project. Step number two is reading your existing rules, and then based off of those rules and the assessment, it would write a prompt, not code. It would write a prompt or a spec or whatever you want to call it that would be passed on to an LLM, an agent, a different session altogether on how it can help me write that CDK. That means that second session would be completely isolated from the first session because it would never see the SAM code, it would never see the serverless code. So there would be no confusions in like translating certain values like duration to seconds or whatnot to CDK. Do you think that would be better than just like having it in a single context?
I mean, like isolated context versus like a continuous, like a session driven by context. It's possible. At the end of the day, if you look at like any coding assistant or coding agent, the end of the day, whatever they get is like a bunch of text, right?
Yeah.
So even if I'm sending it isolated text, just about like building something CDK, it might work. It might work. Just that like if the LLM is trained on both serverless and CDK equally. Probably having a bigger context would give it like a bit more data. That's what at least like my feel would be, that it would have like a context of what serverless V3 or like SAM would look like with this. And I want to take this and use this entire knowledge to build a CDK project. Again, I haven't tested it, just guessing in my head at this point.
Yeah, that's why I'm just discussing this. I also want to hear what chat thinks. Would that be a better option or not? The reason I'm asking is that like I love to start new sessions with LLMs when building something because it feels like a fresh start, and like I feel like it's not burdened by a bunch of previous tokens that may confuse its decisions or whatnot. So like giving it incredibly clear instructions here what you should be doing and just letting it do it, it feels a little bit more precise for me. I don't know.
Yeah, it's a really good point. And actually, I like the idea of feeding it just like an assessment and saying build CDK, and then maybe even after that, giving it back the original code and saying, has anything changed from this code? It's almost just like a second opinion, right? You're doing it in reverse and getting a second opinion saying, hey, LLM judge, right? Yeah. And you can use two different models. You can do all kinds of stuff with this. You can use MCP in the loop, right? You can do all kinds of stuff to build a process that's a little more robust.
And with QCLI and its profiles or personas, agents, I don't know.
Yep. Exactly. Yeah. You can use personas. You can do all kinds of stuff.
You can use a different persona for like CDK generation, where you can just have it. Here's a list of MCP servers you support, and here's a bunch of other stuff you have to do, and then they would be kind of separate from those things and wouldn't potentially poison each other, if that makes sense. And then a third one would be the judge, and maybe that's a thing that we could test out and see if that's an improvement or not. But a comment here from Mr. Sider saying talking about my makefiles. Until it reads your makefiles and creates that file to enable it. Well, here's the thing. I've seen this happen in the past. I've seen LLMs. I had a friend, he writes tests, but that's how he does it. He writes tests first and then just lets LLM pass those tests. So one day, an LLM decided just to pass the test by modifying the tests, which is just great. Supercomputer. Like I love that. That's how you win a war, right? So what he ended up doing, he had to chmod 400 those tests. So like only he could modify them. So the same goes for a makefile. Make a chmod 400 on that makefile. Have nobody else test it or whatnot. So modify it or that'd be just great. Okay. Somebody says they missed my background. Yeah, I know. I'm not in my home office right now. So you get the studio set up here. Debasis and Joshua, I have a home setup with a bunch of old computers behind me. That's what people are mentioning here. So amazing. Somebody saying something you guys should tell the Kiro team. Hey, the Kiro team is working great, by the way. A lot of updates and changes on that one. So I'm going to be doing a live stream on Kiro this Thursday, so stay tuned. Okay, so have you seen, like, I know we're talking about like this, but like, but why should I be translating this like this instead of manually? Is there any benefits to it? Is it faster? Is it more efficient? What have you noticed? Any significant differences?
Speed. That's the name of the game. Speed.
Okay.
I have been doing this for like last 7.5, 8 years, and it takes me like multiple cycles to read, refine, especially like declarative languages like SAM or something, to format them, properly understand it, validate it, test it, and then push it to like AWS Cloud only in dev environment. If you ask me as a developer with my capacity and my knowledge, whatever used to take me 8 hours, now I can do it in 1 hour, half an hour, probably. So that's the kind of pace that I'm looking at. Again, it basically reinforces your knowledge and helps you move faster between like generating a code, building, developing, sanitizing it, validating it, and then pushing it into AWS Cloud.
Okay, that's pretty cool. Amazing. Okay. Any advice you would give to chat here to the organizations, basically folks who are looking forward to adopting coding assistants to help transform their infrastructure management and DevOps and whatnot? Because here's the thing: I have a friend who uses a coding assistant to manage networks. Like he just tells it, flip a bunch of switches, and it goes into the Cisco command line and does a whole lot of things. Any feedback, any suggestions you would give people out there?
Yeah, I think when you look at enterprise level DevOps, repeatability, like what you really want, and this isn't specific to this project or this process, but in general, a governance framework that guides what do those rules look like? What are our standards for these rules? Do we have a library of reusable base components and primitives you can use for rules, right? Do we version control these rules, right? Things like that are so important when you're looking at just like zooming out. And these are standards for DevOps, LLM ops, anything ops you want to look at, right? But that doesn't mean they're any less important. You want structured processes that are not ad hoc, right? So that's the first thing, is just all the standards, right? Version control, code controls, governance. The other thing I would say, and you brought this up with the Makefile, it's phase gating, right? Like structured workflow, assess. I mean, the way we have it here is assess, translate, test, and refine, and then deploy. You could add steps to that, right? You could have different checkpoints. You could have, two-person rules, things like that. You could do all kinds of stuff that's creative with the way you gate things, but just in general, right? Don't skip validations. And that's part of your governance too, right? It's all ties together.
Yeah.
Okay.
Yeah. Yeah. Governance sounds like a scary word, but is incredibly critical in the world of managing infrastructure, especially at scale. But especially now with coding assistants that can help you do a bunch of stuff way faster, you still need to remain in control no matter how fast you're going. So. Governance is a very key thing. So definitely check out that link in the chat. I will ask Jeffrey, if Jeffrey can post a link to the blog post once again about this whole infrastructure as code transformation, so folks in the chat can pick it up. Definitely give it a read. It's a great thing. It also includes a code. There's a link to the GitHub repo with the assessment rules and basically the instructions how you can do this right now. You literally just need a coding assistant, whatever you want. Amazon Q developers kind of like has been trained on these tools a little bit better, so maybe that could help you use it. You can use it for free. So definitely my choice here would be the Amazon Q CLI because shout outs to the command line. It's just the best place to be. So definitely go check that out. Anything we've missed, Joshua and Debasis?
Nope, that's pretty
skipped.
That's great.
Okay, so what's next for this project?
Kiro. I would certainly like to do this with Kiro. Kiro is like a little bit, it divides those tasks into individual level. So if you look at Kiro, you can run tasks one by one. That gives you more control over like the translation itself, right? So that's what I loved about it. It takes its own time, understands the requirement, divided the task. And what Kiro can do, what I saw with like Claude 3.5 and 4, if you draw a picture of it, what you intend to build it, and drop it in Kiro's workspace, it can generate a serverless project for you with that too, right? So now you do both of them. You put the picture, you put the context and everything. So it has all the knowledge and can do a better job for you.
So we're going to go from framework to framework. We're going to evolve it to cartoon to framework. Right?
Okay, cartoon to framework. Yeah. I would love it to be like a dance to framework. Like I will dance my infrastructure, how I want it to look. There's an EC2 Lambda function. And then it kind of creates a SAM template from that one day. That'd be just great. But yeah, you're right. Like in Kiro, like you could potentially use things like steering docs to help you kind of make this work, because steering docs are basically just rules, and they can help you definitely instruct Kiro in how to generate those specs and technical documentation. So I like that. I like that very much. Amazing. Well, chat. Do not forget to check out the links in the chat. That's the most important link, the little infrastructure thing here under our faces. Check out that blog post. Definitely go give Josh and Debasis a shout out. Thank you both for joining me so much. I appreciate it. Thank you, chat, for bearing with me, not being Julian, but next time. Julian is coming back, and he's going to do, well, your favorite serverless office hours. Thank you so much, my friends. We'll be seeing you all. I don't know. Is it next week? I think it's next week. I don't know how often Julian does this show, but next episode of Serverless Office Hours, something else serverless. Thank you all.
Thank you.
Bye.
Thanks so much, Darko. Thank you, everyone.
Bye-bye.
Bye.